Good. So let me tell you how I think of what conceptual amelioration aims to do. So it aims at identifying ways in which, say, language or conceptual repertoires, we can think of this either in terms of interpersonal communication or in terms of thought, can be improved so as to better fulfill whatever roles we have tasked these conceptual repertoires and these kind of linguistic repertoires, lexical items to with. So, for instance, chiefly, at least many times when we talk about concepts, we have tagged them with categorizing entities, say inductive reasoning and other sorts of abductive reasoning as well. And here I've said they can be improved so as to better fulfill, and then what counts as better is an open question and one that I will be discussing in my talk. But we can say to begin with that there will be, first, of course, there will be epistemic goals. So so as to subserve explanation, or so as to aid discovery, empirical discovery, say, etc. But also so as to improve or preserve or be faithful to logical consistency, and perhaps most importantly, so as to fall in line with our social justice goals, or social reform objectives, and so on. So many people have said, and I think it stands to reason, that this is Capellen, at a foundation of a theory of conceptual engineering, you should have a theory of metasemantics. So you should have some understanding of what it is for something, what it is for a concept to mean, what it means, and how these entities are endowed with the meanings that they have, and how these entities start being about the entities they are, and so on. And I will take this idea seriously, and I'm also more optimistic than others, in particular than Edouard Machery, about the viability of some unified metasemantics of concepts. And I will explain in the first part of the talk why this idea of a unified metasemantics might be problematic or complicated, or why people have kind of disparaged of making it work, in particular Machery in his 2009 book and onwards. So I will kind of sketch here for you what I take to be an interesting, initially plausible metasemantic sketch for concepts. And then I will show that this sketch has some consequences for how we should think of concept amelioration. So how we should think for the prospects of this ever happening, and how we should think of the way to make it happen if it could happen. And just to spoil the rest of the talk, in a nutshell, the idea is that it can be done. I think that it makes sense to think that contra what some people have said, it makes sense to think of this process of concept amelioration as something that can be meaningfully pursued and has some chance to be successful for some concepts, but probably not by tinkering with the concepts themselves. So it's not the concepts that should be that should be the point of intervention for the conceptual engineer, or for the conceptual ameliorators. Right. So the main idea of this metasemantic sketch I was alluding to is that you can think, and you should think, of concepts along information theoretic lines, and I will explain what this is and in what sense I think traditional kind of informational semantic work, based on Dretski's initial kind of spearheading fantastic work, has kind of fallen short of this ideal of kind of making use of the full power of the mathematical theory of communication and what we call information theory proper. So the main idea is that conceptual repertoires should be thought of as something like lossy compression schemes. So what's lossy compression? This is just recovering as much relevant information about, say, the world, if we're talking about concepts, as possible. And one easy way to think about this is to think of actual lossy compression in the extra mental world. So MP3 files, for instance. Those of you who are kind of old like me will remember them. These are audio files which are much smaller than the uncompressed WAV files, but still they sound pretty much equivalently, or not completely, but they give a very reasonable hearing experience to the the person interested. Or JPEG, which is perhaps more common today and more used by everyone here in the room, in the rooms. And a JPEG, just as well, is a compressed version, an lossily compressed version of that, of a bitmap file, in that it doesn't recover the value of each pixel, but just kind of the gist of the picture, and is able to reproduce something that very much looks like a picture, with much less size, with a much smaller size and a much smaller memory footprint and so on. So that's the idea. You recover information about the world, relevant information about the world, for the user of the compression scheme, in a way which is kind of keeps resources at a minimum, at a reasonable minimum. So you do as much compression as possible. So you recover as much relevant information as possible, but given some rate constraints. That is, given how much information can be communicated or can be remembered or can be entertained at any given time. So of course, if you just have to, you want to recover as much information as possible, period, then you should just go with a perfect copy of the world, right? Like lossless copy of the world as it is. But that's not something that we puny human conceivers are able to do. So we have to trade off this need or this kind of wish for as much relevant information as possible with, on the other hand, how much info we can actually keep in mind and communicate from, say, the sensory periphery into higher cognition and into behavior later on. So the right way, I submit, and I've been arguing for a while, the right way to think of this, kind of the right formal way to understand this trade-off between cognitive capacity on the one hand and informational richness on the other hand, is called Rate-Distortion Theory. And this is just one sub-branch of information theory and therefore a sub-branch of applied mathematics. So it's kind of basically a priori science or mathematical branch, but it'll help us think of these two ideas, right? On the one hand, we want to communicate a lot of stuff. On the other hand, we have limited resources. How do we make these things? How do we combine these two desiderata, which are in some tension? Right. So then, once I have explained to you how this information theoretic metasemantic sketch works, I will show, excuse me, the Rate-Distortion Theory does provide some optimality conditions for conceptual repertoire. So it explains what it takes for a conceptual repertoire to be optimal in some sense, given some desiderata. But it doesn't provide, and we will discuss that too, a criterion of change versus abandonment of conceptual repertoire. So we can kind of use Rate-Distortion Theory, at least in simplified, idealized models, to explain, to find out whether a certain way of taking in the world conceptually is optimal given some constraints on both rate and some distortion measures and so on. But it will not provide what counts as, it will not provide the dynamic picture of what counts as change and what counts as abandonment. So I will still argue that it does provide the next best thing, which is a measure of closeness of repertoires. So it would explain how two conceptual repertoires can be seen as being partially overlapping or almost fully overlapping, or being just completely at odds with one another and so on. And then a natural suggestion, but one that I won't pursue here in detail, is that if you have very close conceptual repertoires, we should be talking of change. And if we have farther away conceptual repertoires, then perhaps the farther away they are, the more we should be thinking in terms of abandonment and so on. So these distortion measures that we will use, I mean, all of this is, I'm just kind of throwing terminology at you, but in a minute I will be unpacking all of this and hopefully it would be easy to follow. These distortion measures are the natural points of intervention. So this goals of communication, the kinds of things that we want to happen with the communication exchanges and so on. So that the kinds of information that we wish were preserved through noise and through communication bottlenecks and so on. In this theory are encoded as what we call distortion measures, and I will explain what they are. And these are the natural points of intervention. So we should not think of amelioration of concepts as something having to do with tinkering with the concepts themselves, but actually as, you do that one kind of step removed, step before that, and you do it through the distortion measures. But we'll be discussing that in a minute. So I'll start by giving this rate-distortion metasemantics for concepts, and then I will explain how it applies to the prospects of the project of concept amelioration for some concepts. Good. So what's a concept to begin with? So I'm following Machery here. One rough and ready characterization is this idea that the concept of something, of X, is a body of knowledge about that thing that is stored in long-term memory and used by default in processing underlying many cognitive competencies when this process results in judgments about X. So X should be thought of as a class, so an extra-mental set of individuals, perhaps some kind of natural class of some sort, natural kindy in some ways, but basically a set of individuals, concrete entities. And the cognitive competencies in question are, as I was saying before, things like categorization, inductive reasoning, and so on. So we use our concepts and they result in judgments about the class, such as this entity belongs to the class, so this entity is a woman, say, or inductive reasoning about the class. So, all women are like this or like that, all men are like this or like that, or many men are like this or like that. So these bodies of knowledge that here Machery was alluding to, this kind of things that you hold in mind and kind of constitute your concept. What are they? Well, as you know, there are many theories in the marketplace. I will just give you the most famous 3 families of theories. And actually, it's basically 2 of them. So, but I won't have time to discuss this here. But at least 2 of these theories can be seen as just ways of thinking of the same kind of things, with perspectives on the same kind of thing. But anyway, prototypes first are statistical bodies of knowledge about a class. So some summary of some sort of the central tendencies of the class. This was, as you probably know, spearheaded by Eleanor Roche in the 70s. Here you have the central tendency of the category, a list of frequently occurring features, or perhaps an ideal category member. And exemplars is the second of these families, are particular instances of the class. So that particular sparrow, or that particular wren, or that particular stork. Also, those are the things, or perhaps a set of different. Every stork I have encountered in my life, every cat I have, owned in my life, or whatever. Those would be the exemplars that are the bodies of knowledge. So our knowledge of those exemplars would be the bodies of knowledge that Machery was discussing, one of the possible candidates, say. And then you have the candidate of theories. So theories or elements of theories about the class. So you could say that many people have said, Susan Carey, first and most centrally, that you should think of, in developmental psychology, perhaps, you should think of kids and of people as budding scientists, making hypotheses and testing them by empirical means and coming up with theories of the class they're interested in. To give you an example, so this would be one example of a prototype for faces. So here you have this, it's called eigenface model of faces, and the idea is you have a bunch of weights for different parameters. Here you have sliding rules. If you go to that web page, you can play with this, and then by moving these weights, you can actually create a bunch of different faces. And the idea is that the space of human faces is particularly well behaved, and with not too many, here you have 10, but with something like 200 different weights, you have already something that looks very much like a perfect human face, photorealistic human face. So that would be one kind of thing of a prototype. So this distillation of human phase variability into a bunch of parameters, say 10, 20, 50 or whatever. That's an exemplar. So you can think of, instead of thinking of the concept of phase as based on one of the prototypes, you could think of it as based on the exemplar of phases you have seen in your life. And what better phase than Tilda Swinton's. So that's another example of something people have said underlies conceptual competence. And finally, you have this idea of theories. This little picture comes from a paper by Bob Redder, from a series of papers on his account of concepts as causal networks. And the idea is that if you think of a concept, say, he would use in his tasks made up concepts like South African anchovy and things like that. And if you think of one of these concepts as being as implementing a common cause causal network, then you will make very different inferences as what happens with, say, feature number 3 if its feature number 1 is present, then if you think that it actually implements a common effect network in which F3 through F1 conspire to cause F4. So in these cases, you would expect that if people embody or have in mind and code one of these models, then they will make different predictions. Actually, that's what happens, as rather nicely shows in many situations. Okay, so we have this different types of knowledge. All of them have some empirical plausibility. I should say, I was saying that I only think there are 2. I think that exemplars and prototypes go kind of in one hand, and actually exemplars are just a kind of prototype. But I'm happy to discuss that in the Q&A, but that's not the focus of the talk, of course. But anyway, you have this different types of knowledge, and they are each of them better suited to explaining different aspects of our competence in the use of concepts. And each of them does a better job explaining different experimental results. So, typicality effects, the fact that we are, if someone asks us to, give a list of birds, we will typically, when you tabulate answers, you will have much more, copies of sparrow than you will have of penguin and so on. And if you are asked to identify something as a chair, then people will, do it much quickly if it's a typical IKEA chair than it is one of these kind of nice Swedish chairs without back support and so on. So these typicality effects are very well established, and they seem to be something that prototype thinking tracks very well, right? So you think in terms of a prototype, and if the thing is at the center of the prototype, so to say, then it's very easy to come up with a positive decision as to that thing belongs in the extension of the concept. While if it's the periphery, is a fringe member of the class, then no, right? But sometimes you're reasoning about the class, right? I was saying before, when you ask someone, so if something has feathers, will it fly? And people would typically say yes. But if something has a K, what's the most, in English, say an English word has a K, what's the most common letter that would come before that? Then people have to think and so on, and you need to make some or as Fodor famously put, prototypes do not compose because sometimes have spoons on the one hand and wooden utensils on the other hand, and spoons are typically small and wooden utensils are perhaps, I don't know, typically not spoons, but if you have wooden spoon, then that kind of brings in a whole other reason, a whole other kind of a whole universe of properties that this thing will have, and it will be used for cooking, but not for eating, and so on. And these kind of reasonings are not so well accommodated by prototype theories, but they are very well accommodated by theories. So some theories have taken this, apparent difficulty in coming up with one unified body of knowledge that kind of explains everything, have taken them to defend that concepts are something like composites of prototypes on the one hand and theories on the other hand. As I was saying before, some people have even said that there are no such things as concepts, and eliminativism, as also Kapellen has argued, it's kind of very much an alive option in the debate. Right. So I think that the kind of hybrid pluralistic move on the one hand and the eliminativist move on the other hand are premature. You can actually give, I hope, a framework that unifies all of those results nicely. So, and I would say that these bodies of knowledge fall naturally out of an information theoretic understanding of the role of concepts. So, as I was saying before, concepts are to be thought of as lossily compressed encodings of the state of the world. So they say a lot, but not everything about the world. Everything that is relevant, not everything that's relevant, but a lot that is relevant to the thinking subject in an economic way, right? So they kind of optimally, in some principal sense of optimal, solve this trade-off between richness and sparsity of resources and so on. And prototype exemplars and theories can arise naturally as an answer to the following question. So given the available capacity of a certain channel, and we can think of it as a channel, in the brain from, perception to higher cognition perhaps, or, communicative channels afforded by natural languages such as English. Given that capacity, how should one encode information incoming from the world so as to minimize errors in the picture that we form of it, right? So we want to have a picture of the world, we want to communicate sometimes a picture of the world. We want to minimize errors in that picture, and we have to work around or work with the limitations of cognitive channels and social channels, right? So of our brains being limited engines, and of language and so on being also limited in other ways. So that will be the question that I submit. Will make prototypes and theories arise naturally when we come to answer this question. All right, so I said that we'll rely on an information theoretic picture to explain this. So perhaps one thing we should do first is kind of explain what I mean and what information theoreticians mean by information theory, which is not very much what the Dretskian mainstream in philosophy means by information theory. So information theory is this branch of mathematics that is about specifying how faithful transmission of information from a source can be when it happens over a typically noisy, typically narrow channel, right? So if you think of what Dretske cared about mostly, and contemporary Dretskians such as Scalantino and many others, Brian Skirms and many others, perhaps Nick Shea, Ruth Milligan, etc., think was relevant is correlation between some vehicles, say a linguistic vehicle or a mental vehicle or a brain vehicle, and some state of the world, right? Insofar as you have this correlation, that's where information kind of helps build the metasemantic picture. But it doesn't, so this whole idea that what you need actually is the whole information processing pipeline, right? So the source being encoded and then being thrust through a channel that doesn't have enough, many times, as much capacity as we would like it to, and then be decoded so as to be used elsewhere. That whole pipeline is, I'm suggesting, what's going to be relevant to understanding the role of concepts. So not just the idea of covariation that is typical in the philosophy of mind, at least, perhaps. Right, so let me just explain very quickly what these things mean. So information about something, about some state of affairs or a family of states of affairs that might be relevant to us, is generated at a source. Some aspect of the world the subject has access to. So, it could be things, whatever, it could be colors, it could be birds, but it could be also, types of human being, and so on. And of course, different things will have different societal and justice and fairness related issues linked to them. So information is generated at the source, and that just means that the source has some value which is uncertain for us, right? So if we wanted to know perfectly well what the source is, then we would need to ask some questions, right? Suppose that the source is a very simple coin toss, then we would minimally have to ask, if we wanted to know the value of the source, we would typically minimally have to ask, was the result heads? And then if the answer yes, we know it was heads. If the answer no, we know it was tails. And that's that kind of fixes the relevant aspects of the source for us, right? So in this case, because you can make do with just one yes/no question, we would say that that source, a coin toss of a fair coin, has just one bit of we say entropy, right, or informational content, if you wish. So the encoder then takes this value that comes from the source, we'll call it M for message, and will output a signal. And that signal should be both optimally compressed, so kind of it should say as much about the world, as I was saying before, as possible, given the kind of the available repertoire of signals, and also should be protected so as to go through a channel that might be noisy and so on. But today we will only be interested in this compression thing, right? So the encoder should take this state of the world that might be a coin toss, or it might be a very complicated, it could be a picture, it could be a situation as complicated as you wish, and then it should turn it, encode it into signals that, as I was saying before, recovers the gist of the situation as much as possible, or even more than the gist if possible, but while preserving cognitive resources as much as possible too, right? And then the decoder has to reconstruct this original message. So we had M here, and you get M hat here, which is a reconstruction of the message. And then processes downstream can use M hat as a reliable guide for M for the purposes of the system. So this is information theory, but this kind of speaks to many of the ways cognitive scientists have thought of conceptual repertoire. So for instance, I was talking before about Eleanor Roche. She says cognitive economy is one of the main principles underlying categorization. And what she means by cognitive economy is that what one wishes to gain from one's categories, which I take to be, at least for the purposes of categorization, just concepts, is a great deal of information about the environment while conserving finite resources as much as possible, right? So we want to have a great deal of information while conserving finite resources, which is just what you want to do in information theory. So you have this bunch of stuff coming from the source, and you want to send it through a channel, which will be, you will try to provision for the narrowest possible channel, say, make your language as synthetic as possible and as concise as possible, or make your brain processes, not waste time in things you don't really want to know and really you care about. And that's a trade-off that cognitive economy puts at the foundation of conceptual repertoires. That was Roche in the 70s, but this is also what Tenenbaum and colleagues and many other cognitive scientists have said more recently. So for instance, here, your computational rationality, what they call is kind of a emerging paradigm that everybody in CogSci and in computer science and everything kind of thinks with these days, is identifying decisions with the highest expected utility, which take into consideration the costs of computation in complex real-world problems in which most relevant calculations can only be approximated. So we have this. It's always the same, right? So if you remember that story by Jorge Luis Borges, in which you wanted to create a map of the world, and you wanted it to be as precise as possible, but of course Borges said, if you really wanted all the detail, it had to be just as large as the country you were trying to map, right? So you need to make you need to cut stuff, and you need to make compromise, reach compromises and make sacrifices. Okay, so just an introduction to the branch of information theory that does what I was saying we need to do to think of concepts. So information theory, let's see, what time is it? Deals with lossy transmission by defining a distortion measure, which is just a score for a pair of an original message and a decoded version. So perhaps if they are both binary sequences, you just count a number of errors and then normalize. But we should not think of M hat as a degraded copy of M. A distortion measure is just a score that could connect every two different domains. So for instance, percepts to motor programs, if you're thinking of thought, or goings on in the world to extramental social consequences as well. So all of that could be a distortion measure if it gives you a score you can work with. So any loss function, really. So just to give you an example of how this works, this is very quickly, this is a coin toss I was telling you about before. So suppose that you have, you toss a coin and you want someone else to know the value of the result of the coin toss. Then if you have one bit of information, you can give the full information with zero distortion, right? Because you just need one yes, no question. I was saying you could just say, was it heads? And that's all you need to know. If it was, if the answer is no, then it was tails. If there is yes, then it was heads. So you only need one answer to a question. If you get zero rate on the other hand, so if you have no information going through the channel, then you have just to work at random, right? So you can only guess what the outcome was, and therefore your distortion would be 0.5. So you will get it right half of the times if it's a fair coin, and you will get it wrong half of the times, and that's the best you can do. Right? So this is the rate distortion function for every rate possible and for every distortion possible, and this is the slope of the function. So it just means how steep. So the red line is just how steep the blue line is, okay? And this will be important in a second. So we will care about when there are steep kind of or sudden changes in this slope as signaling points at which our concept repertoire will typically latch onto. So of course, the coin tosses can only take us this far. We will be more interested in things which mimic natural entities of sorts, right? So for instance, we could be interested in conceptualizing a world which is form of one, as Richard Boyd would call it, homeostatic property clusters. You have some essence which perhaps that you don't have access to, and this essence gives rise to 9 different properties in kind of a noisy manner. So if the essence is present, each property has a 0.95 probability of being instantiated and 0.05 otherwise. And the essence itself is a coin toss, whether it is instantiated or not. So remember what we saw before. This was the fair coin toss rate distortion curve. If we have this other situation, then we no longer have this unstructured curve. Now we have a clear kind of point in which you change the slope of the blue line. So there is kind of a lot of gain in reduction of distortion when you go from 0 to 1 bit of rate. But then if you want to really get to know more about what the values of the different 9 properties is, then you need to spend almost more than 2 times the rate you use to kind of to get you all the way to from 0.5 to from a chance performance to almost no distortion. You do that with 1 bit, and then you need a bunch of rate to get you to the rest of the to get to 0 distortion. So it's just one of these 80-20 things. So it's not 80-20, it's even better. So if you have 25% of the rate, that gives you 95 almost % of the distortion accounted for. And if you really want to kind of get right the rest of the values of the 9 properties, then you need all of this other rate here, right? So you have this interesting kind of sweet spot of sorts, and I suggest that that's where, you know, when we have these kind of situations, a natural or hopefully natural enough world situation, and not natural in the statistical sense, of course, in the probabilistic sense, then our conceptual repertoires will gravitate towards this points of change in slope. So just to show you how it works, suppose that you want to sit precisely here. You want to sit at precisely the point at which the slope starts changing. Then what you need to do is to first apply a majority rule to the properties you're seeing, to the 9 properties in the homeostatic property cluster. And then you set the bit to 1 or 0 if the majority was 1 or the majority was 0. And you then decode the resulting message, substituting this 1 by 9 ones and this 0 by 9 zeros. The idea would be, if someone sees the world and sees the instantiation of those 9 properties and is to communicate with you what is happening over there, there's a principal sense in the kind of a sweet spot sense of principle. There's a principal sense in which the best you can do is send in 1 bit. And then the person on the other side will have to decode that in terms of the paradigmatic instance of that entity. So because the paradigmatic instance is having the 9 properties replicate the essence, that's what they're going to be doing. And that's the best way you can make sure that you get the maximum the minimum distortion out of that 1 bit of rate. I hope this was clear, but let me know if it wasn't in the Q&A. So identifying concepts with the signal and the associated encoding and decoding rules, that gets us the bodies of knowledge that are associated with concepts. So the encoding strategy is something like a categorization rule. And by the way, majority rules, as the ones we were using here in the optimal case, present typicality effects. And upon reception of a signal, what the decoding strategy produces is the most typical member of the class. You can think of it in terms of an exemplar, or you can think of it in terms of a, kind of the central tendency of the class, as Smith and Aminda were saying, for further downstream processing, which is just simple prototype. Okay, so if the source is more complicated than just your single homeostatic property cluster, then you will start encoding and decoding, if you want to do it optimally, in ways which resemble more something like a theory, right? So the more complicated the source graph is and the distortion measure is, the more sophisticated and theory-like optimal encoding decoding pairs will be. So suppose now that we have this sexual dimorph here. So you have some essence at the top of the causal network, and you have 3 kind of properties which are common to both dimorphs, and then you have a sex node which gives rise to a syndrome of male properties and a syndrome of female properties, which are mostly incompatible but not completely. So that there's some noise. You can have some female properties in a male cluster and so on. And replication is noisy as before. So the essence is again a coin toss, and then the sex is supposed to be another coin toss, and then you have noisy replication here, noisy replication there, and noisy replication there. Then you also have one clear sweet spot now at the rate of 1.5 bits, which was, I think, just as expected. So what's the decoder doing? So first the encoder, half of the time there's nothing there, and so a 0 is sent. So there's no male or female entity, just a 0 is sent. But the other half of the time, there's either a female and then a 1 0 is sent, or a male and then a 1 1 is sent. So this signal is kind of distinguished between a common part, that's the first bit, and a sexed part, that will be the second bit. So the encoder is kind of able to distinguish between the 2 dimorphs, and it keeps track of these 3 nodes, keeps track of essence, of sex, of male, of female, and so on. So it's kind of constructing this idealized theory of what sexual dimorphism in this idealized species would look like. And the decoder recognizes 2 exemplars. So 111001111, which is just the prototypical male, and 111111000, which will be the prototypical female, right? Okay. So that's kind of the model, the sketch of how, one way of thinking of concepts that kind of, as I was saying, recovers nicely some of the things that people have asked of theory of concepts. Now, how should we think of amelioration here? So the first thing, so why change our concept, right? So of course, one thing that could happen is that a conceptual repertoire sits far from the informational optimum. So that thing would be this point here, right? Of course, it could be sitting somewhere over here, and that would mean expending much more rate than necessary to get at that distortion, that spectral distortion. If you're here, you should be here. And if you're here, you should be there, right? But I mean, of course, that could happen, and that's one way in which you could ameliorate your concepts. So this is important perhaps, but I think perhaps less frequent than it looks than it might possibly be. So there's lots of recent evidence that many, at least well-behaved conceptual repertoires are informationally optimum. So color vocabulary is approximately informationally optimal, and you have color vocabularies in world languages kind of sitting very much just, kind of touching something like the rate distortion curve. This is done in terms of another formalism, but it's kind of similar. So they're sitting at precisely the right place you would expect them to sit if they were optimal. So when, for instance, Capellen says things like, could dark red be seen as an amelioration of red? It says, no, that's ridiculous. You have just started talking about something else. It's true that singular concepts cannot be ameliorations of other concepts, perhaps, in some sense. we will get to that in a minute. But of course, if you have some, you say you have a 4-color vocabulary, 4-word color vocabulary, then dark red might be better or worse than red in covering as optimally as possible this, in kind of trading off richness of information and cognitive resources. So no, this question has an answer in natural contexts. It's just these full repertoires and not singular concepts that have it. This is another example for kinship vocabulary. So, terms like nephew and brother and sister and mother and so on. And that across language is also approximately optimal, in slightly different terms, but you get kind of the same result or morale out of the exercise. And there are many more examples. There's this Gibson et al. Recent review that you might look into if you're interested. It's called the efficiency approach to languages. Okay, so there's this argument by Capellen. It says the argument from many alternatives that if you have a word that has some kind of meaning, then there are of course many similar meanings that the word could have had. Take one of those M star meanings, and it could be, it's just a matter of happenstance and of path dependence and randomness that the W ends up meaning M rather than M star. And it's just unlikely, he says, this is my emphasis, that these random factors have assigned the best meaning to W. There are many alternatives. So why would we expect our meanings to be optimal? So that's, at least incomplete. There are reasons to think that, as I just showed, that, cultural pressures and cognitive pressures will take our vocabularies and lexical items and our lexicons and our conceptual repertoires to optimal configurations, at least often, right? So this is a bit too quick. So then suppose we assume now, for the sake of the argument, optimality. When will conceptual change therefore be necessary? Well, it will be necessary at least in 2 situations. When the makeup of the channel changes. So if we have, we used to be creatures with not too much memory, but now we gain a lot of memory. That might, change what we find useful to preserve, because, we don't need to sacrifice it anymore, something like that. That's intriguing, and I will ignore it. But, think of extended mind kind of ideas. So if we now have more kind of cognitive scaffolding that we used to, it might just be that, we are able to make do with more nuanced conceptual repertoires. That's an option that might happen. I think most importantly, conceptual change will be necessary, and amelioration will be necessary when transmission priorities change. So as social norms change, and as what we want our concepts to do for us change, that will reflect in this kind of formal way of thinking of these things as a new distortion measure. And a new distortion measure will call for a full reconfiguration, full or partial, of the whole conceptual repertoire. So if you have like new, we want to keep this, we want to keep that, then suppose, for instance, that you are compressing MP3 files for yourself. And, as you get older, you start losing track of, very high frequencies, and you might just tinker with your encoder so that you stop disregarding frequencies which were central to your hearing experience when you were younger, but you don't care about them anymore, and you can shave off a few bits. You might be able to do that. So something like that, but more complicated, is what happens when transmission priorities change. So let me give you an example, a laughably simplistic example, of course. I want to make this clear. I'm not suggesting in any way that this is analogous to anything that's really important happening to human beings. But let's suppose that we have a node that chooses now. So, a transition from sex to gender in public discourse. Suppose you have a node that, decides whether you have a female or a male in the sexual sense, right? So a female sex or a male sex individual. And now these things have some sex-related properties, F1 and F2, or M1 and M2, and some gender-related properties, which are, you can think of them as, self-identification choices and other social relevant properties. And, these tend to go with the sex, but they do not necessarily go with the sex. And you have, these nodes have looser probabilistic connections to, so M super G has looser probabilistic connections to F super G and F super G2 and so on, and F does the same. But you could have everything of everything, but there are these kind of tighter or looser probabilistic connections. And if someone is interested in the model, I'm very happy to send it to them. So again, it's a two-way model, not intended and hopefully enabled to portray the actual struggle of trans men and women. So please, I need to say that, but take me to task if you think you need to, of course. Right, so suppose we first care more about sex-related properties, right? So we want to get this right, and we don't care so much about getting this right. Then we have our usual sweet spot at 1 bit, right? We just have a concept which is governed by male or female. And the decoder sees everything as the paradigmatic cis male or the paradigmatic cis female in this very simple example. But now suppose that we start caring more about gender-related properties than about sex-related properties. Then you just, the sweet spot disappears. Things are much more complicated now. And the decoder now uses a bunch of different syndromes of properties to kind of try to maximize how many properties it will get right in the end. This one, this syndrome here, this syndrome there, etc. Right? So gender-based conceptualization, as modeled, is a harder problem than sex-based conceptualization. And so you would get this, that if you have a tendency to stay at a similar rate, so you still want to have 1 bit of information to kind of talk about these topics, that might have distorting effects. So sticking to a binary classification, even when the implicit distortion measure has started caring more about gender, that might cause problems, right? So why is that? It's because some distortion measures are harder to meet than others, and call for a more nuanced conceptual repertoire. So what's a preliminary lesson for conceptual amelioration of this very simple exercise? So suppose, assume skeptics are right, and conceptual amelioration is very, very hard. So it's very hard to move concepts around, to budge concepts and so on. Perhaps that's okay. So we should only care about engineering distortion measure changes and let cultural and cognitive drives for communication efficiency take care of the actual concept. So the concept is not something perhaps that we are able to actually engineer themselves, but we can kind of localize and then do social protests and social reform activities and so on to kind of change what we want to get out of our communication exercises, right? So we can try to make distortion measures change, and also perhaps engineering these measures, making people care about different things, is likely less hard than making them talk or think in different terms. And we can expect that if we really are able to kind of change what people care about, then the conceptual repertoire will take care of itself. So the task of the conceptual engineer is not to actually draft the new conceptual repertoire. That's micromanagement. So that's not something that we can perhaps do or we should be doing. So it's rather to formulate new stuff to care about in that area of discourse. So what conceptual engineers should be doing, I'm suggesting here, and I would very much like to know what you think about this, is, so take for instance, is to kind of formulate what it is that we should care about in the area of discourse that interests us. Suppose, extended mind people, Chalmers and Clark kind of people. We should not jump to conclusions about what belief means, the concept, but theorizing about what we should be keeping track of in the era of cognitive scaffolding. So now we have all of this kind of outsourcing of memory and so on, things that people, techno people talk about. What do we need to keep track of if we want to understand behavior as well or better than we did in the past, right? So that's what's important. And then we'll just sit back and wait for the concepts to emerge, which they will do, but not by our own micromanagement, perhaps. Right, so how much time do I have? Perhaps 5 minutes or 10 minutes? Great. So with the function of our conceptual repertoire, so when the function changes, and I think this means when the distortion function changes, then this changes the concepts themselves are hard to predict, right? So, when we're talking about color, lexicon, and kinship, vocabulary, and so on, it's just very hard to work out how do we need to partition our subjective color space so as to come with the first 5 color word vocabulary. That's not something for, that's not something for, humans do. I mean, it can be done, but it's just very hard. It's kind of easier to let the changes happen, you know, like pebbles in a river and so on. So to let it happen through the friction with the actual communicational problems in the real world, right? Same with concepts, with the concept of woman, perhaps. And you know, it's hard to see where concepts are going, but perhaps optimality analysis, such as Rate-Distortion Theory based ones, can help. So if you see what's the optimum, what's the kind of what's the best you can do given a certain communication problem, that can help understand how your concepts could be going. It's not saying that, you know, we have perfect adaptation and so on, but it makes sense to provide this kind of vantage point at will to see from which to see actual adaptations. Of course, we should be alive to the possibility that changing the problem implies changing the number of concepts, of the size of vocabulary, so investing less or more rate in the problem in question. So we should be ready to. So that's one thing that I think, you know, thinking of the single concept as the locus of intervention, the point of intervention, gets wrong. So if you think of, you know, we have now, say, 2 words for gender, right? We have to have a bunch more because of the things I was discussing before, perhaps, or who knows. But suppose we had, you know, mainly 2 words back in the day. It would be silly and it would be bad, perhaps, to expect that new situations should be covered as well with a binary decision, right? It could be that we need to invest less or more rate as problems become more complicated or less complicated, and as our social norms force us to kind of communicate more information about something or less information about something. Very quickly, because I'm running out of time, let me talk about, you know, change and abandonment. So let me give you another toy example, even more toy example than before. Suppose that you have just 4 different things, right? A's and B's and C's and D's. And you think of them as being A is 0, 0, B is 0, 1, C is 1, 0, and D is 1, 1. Suppose that your starting distortion measure, so the thing that people care about most, right, when you're thinking about the A, B, C's, and D's, is the value of the first half of the world state. So you just care about the first bit in those 2-bit sequences. And if you only care about that, then you can make do with just 1 bit, right? Because you can achieve lossless in the sense of no distortion transmission with 1 bit by treating A and B as equivalent and C and D as equivalent, right? Because you only care about the first bit. Now suppose that you know, there's a, you know, social upheaval and revolutions and so on, and then you only care about the second bit. And if you do that, then your conceptual repertoire needs to change, and now you will have one which is perfectly at cross purposes from the first one. So you will start treating A and C as equivalent and B and D as equivalent, because you now only care about this second bit here, right? So you only care about the 0, which makes A and C equivalent, and only about the 1, which is B and D equivalent. So that would be kind of the poster case of abandonment. If you have this kind of brutal change in what people care about when discussing about the A's, B's, C's, and D's, then you will have abandonment. So a possible, just kind of this suggest a possible measure. So in abandonment, you have a situation in which the new concepts kind of tell you very little about what the reference of the old concepts were. So, you know, in semi-formal terms, the mutual information between decoded messages according to the old conceptual repertoire and the new one will be typically very low. So one kind of use the new conceptual repertoire as a guide to reconstructing the old one and vice versa, because the ways they categorize phenomena are very different. And in change, as opposed to abandonment, this mutual information will be typically high. So one can make, for instance, now reasonably educated guesses about the sex-based classification of people by looking at their gender-based classification. Imperfect ones and noisy ones, but reasonable ones, not fully at random ones, right? Now, of course, typically high and typically low, that's not a hard criterion by any means. And it would be perhaps silly to just try to come up with one numerical threshold of mutual information. But it does provide perhaps this subvenient base for the change abandonment frontier. So, you know, as these things grow up, you could think of this in terms of supervaluationism, perhaps, and think that change abandonment frontiers would be is vague, but could be specific. That word, by looking into mutual information. That would be the idea. And perhaps this is the best one can do, right? We cannot, you know, be more precise about what change means and what abandonment means, but just providing this kind of subvenient base for the change abandonment talk. Right. So to finish, this is the quantities I have been discussing and working with. So repertoire closeness and communication efficiency could possibly interact. So optimal efficiency, suppose that we have one situation, and then as in the ABCD case, and we now move to another situation, and now the optimal new conceptual repertoire implies abandonment of the old. So it just implies choosing a completely new vocabulary. But perhaps slightly less than optimal efficiency only implies incremental changes in repertoire. Suppose that would be the situation, right? So we could have, you know, full optimality in the new repertoire, but that would imply abandonment. But slightly less than optimal efficiency only implies incremental change. Then in this specific situation, perhaps cognitive stickiness might take us to an all things considered optimum that is not the absolute communication optimum. And I don't know how this you know, would pan out, and I'm just leaving it here as a suggestion. So you would need to think. So if you try to introduce a dynamic perspective into this kind of information theoretic businesses, then you would need to take into account this cognitive stickiness in some way or another. Right, so let me give you some conclusions. So there are at least 3 constraints to some conceptual repertoire. A distortion measure, that is what we care about communicating or thinking correctly when using that repertoire. A rate, so how much conceptual nuance and richness are we willing to spend in meeting our distortion goals? How much cognitive effort are we willing to spend in talking about the subject matter? And how close to the rate distortion optimum we are. So how good a use of our rate allowance are we making in meeting our distortion goals? And I think I suspect conceptual engineers have not always kept these 3 constraints clearly separated. So as I was saying before, sometimes you know, some of the literature comes across as, you know, facing the task of engineering a concept, but that's not what changes. So when this is perhaps, you know, in some cases it would be a pedantic point. So what changes is always a full repertoire, right? So if you change, you know, if you ameliorate the concept of woman, then you are thereby also changing the concept of man, right? That's of course well understood by everyone, but you know, it's good to, I think, to keep in mind this perspective that what changes is always a full repertoire, never one singular concept. And the questions about, you know, whether dark red and red are better or worse, that's of course a ridiculous question. But when you think of repertoires of colors, and it's you know, far from ridiculous, a very important question, and actually one you can solve empirically and so on. And also, perhaps what can be directed is a distortion measure. So you cannot perhaps direct concepts themselves, but you can channel what distortion measures are, and you can kind of, you know, advocate for social reform, and you can advocate for social justice, and if you're successful, and you can advocate for a different understanding of the cognitive tasks that the person faces in the iPhone era or whatever. And if you do that, then and if you're successful, as I was saying, then you will have succeeded in changing in the public sphere the distortion measure, and therefore hopefully the conceptual repertoire will follow suit. So it's possible that concepts mostly take care of themselves. All right, thank you very much.